Welcome to From the Spectrum podcast. This is a podcast about autism. It is my goal to explain what is autism. I plan to use a mixture of scientific literature, personal experience, and opinion. With opinion, I will explain why I feel the way I do and give examples. I will provide links to various references for each episode. For each episode, we will discuss various aspects of autism. The From the Spectrum podcast will mostly avoid causes of autism, and I will try to avoid the increase of diagnoses of late. This is like playing tug of war with barbed wire, and I don't think I want to travel down that path. For today's episode, we will explore the roles of oxytocin and vasopressin with human development, human socialness, and the implications to autism. We will briefly do some time traveling to understand the phylogenetics of oxytocin and vasopressin. We will expand on some components of the excitation-inhibition balance. Discuss more serotonin, dopamine, and the line between socialness and anxiety, while connecting many brain regions and functions previously discussed. For today's episode, we have several objectives. 1. Introduce oxytocin and vasopressin. 2. Prepare to discuss vast differences found between female and male autistics in a future episode. 3. To prepare for the episode on autism and relationships. 4. To expand on the excitation-inhibition phenomena that is very worthy in autism. And finally, number 5, to learn more about what is autism. Oxytocin and vasopressin. Oxytocin is commonly known as a love hormone, and that's true. Both oxytocin and vasopressin are unique and dynamic parts of our biology. The phylogeny of oxytocin and vasopressin date back 700 million years ago and is found in many different species through evolution. Primarily, back then, there were lower vertebrates. Back before humans and more complex organisms were found on Earth. This hormone is vasotocin. You can see a combination of vasopressin and oxytocin. We could cover a lot here because of the amount of history, but we can't. We can't cover everything regarding our topic in modern humans, development, and autism. However, the division of vasotocin into vasopressin and oxytocin appears to help create more complex organisms like humans. Oxytocin and vasopressin are both peptides and hormones and have 3 modes of transmission. They have 3 methods of getting around the body. 1 is endocrine, so a hormone. Hormones use the blood to transport, and hormones are very slow acting, especially compared to cellular functions. Hormones act more to change us and build us based on experiences over time. The second mode is paracrine, released in dendrites and cell bodies, and into cerebrospinal fluid, or CSF. The CSF is a method to check levels of oxytocin or vasopressin in the body. This is a very challenging test. Not only the spinal tap is challenging, but finding accurate amounts of oxytocin and vasopressin. Now you can do it maybe in a lab draw, a blood draw, but it's hard to capture them because one, they have a short half-life. They don't hang around in the body. And two, you're likely only to see metabolites. It won't be a very accurate test. So a more accurate test is the spinal tap. And that's not necessarily a feasible thing, something that people want to do. The third is synaptic release, used for transporting to other brain regions. This is the neuropeptide or neurotransmitter type. Okay, so what are peptides? Peptides are a chain of protein collections. Oxytocin and vasopressin are very fascinating, whereby they are very similar and they have a smaller complex or smaller collection of proteins. Each, oxytocin and vasopressin, each contain 9 proteins. These are very special types of proteins. Amino acids. We've discussed some amino acids like tryptophan and tyrosine. Those are aromatic amino acids. Remember, serotonin comes from tryptophan, and dopamine, epinephrine, norepinephrine, and melanin comes from tyrosine. And remember our discussion on these special amino acids, the aromatic amino acids that need 280 nanometer wavelength light, which is UVB light, to activate. And think about how our light environment has changed. Let's say from modern day and all the different light sources to the 1930s, just the change between that time frame when autism was first kind of observed. Remember Leo Kanner and Hans Asperger. Now let's think about modern day to, let's say, 200 years ago, when things like autism and Alzheimer's didn't even exist. This part of the environment and how our human biology is created with photoreceptors and such is going to be crucial. And we will discuss serotonin and dopamine more in a little bit. Human biology loves these proteins. Oxytocin and vasopressin share 7 of the 9 proteins. So only 2 proteins make these two different. But remember the evolution. In complex organisms, they separated, they divided. But still today, in smaller or lower complex, less complex organisms, they still remain one. Okay, taking a brief step towards the upstream of the neuropeptide. We're going to go just a little bit upstream. These neuropeptides come from 2 cell types, Magnocellular and Parvocellular. I first learned about these while studying the eyes. Magnocellular provides information about large and fast objects. They are low spatial and high temporal, meaning low space, high time, fast time, and do not pick up color. They are colorblind. Parvocellular provides information about small and slow objects and does see color. They are high spatial and low temporal. Magnocellular peptides release large quantities in the central and peripheral nervous system. This peripheral path will come into play later when we discuss intranasal oxytocin as a treatment option, whereas parvocellular releases small quantities in the central nervous system, in large part to support reward processes, social cognition, and pair bonding. Downstream, magnocellular is responsible for parental attachment, buffering, fear and anxiety, and emotional or affective empathy. Remember, we've discussed that. And hypersensitivity. Parvocellular is responsible for various other types of attachment outside of the parental attachment, such as peer-to-peer. Now we're getting somewhere. And cognitive flexibility and social recognition memory. Cognitive empathy, being able to understand others without knowing, just by looking at them, that so-called theory of mind, and lack of social motivation. So that's magnocellular and parvocellular. Now, these distinct pathways to a single molecule, the idea is the parallel paths for processing this social information allows a single molecule, such as the oxytocin, to encode multiple types of behaviors. And in my opinion, this is a huge finding. This was released in 2020. Furthermore, this idea of the magnocellular and parvocellular paths is new, around 2015 or so, when this was really mentioned in the scientific literature. A keynote, or to show appreciation, a researcher from Johns Hopkins does excellent work on this. Her last name is Dolan, I believe. Okay, back to oxytocin and vasopressin. Oxytocin is central to human reproduction and evolution, transforming us into complex organisms, especially the nervous system, specifically socialness and cognition. The peptides have connections with making us upright through evolution. Remember, humans are one of the few or the only species completely upright. And oxytocin has a role with that. And developing our large cortex, the area of the brain above the imaginary line that we've previously discussed from the eyes to the back of the head. Remember, our heads extend up, unlike any other species. It's fully developed. Also, connections with our cranium. This complex human brain then gives us social sensitivity, complex thinking capacities, and language. Speech and language comes after song and dance. Correct. It was song and dance first, and then speech and language through our evolution. The pair bonding allows us to sustain our species. The connection of reproduction, birthing process, and mother-child relationships. Lastly, it supports healing and is an antioxidant and anti-inflammatory, all crucial across the lifespan. Just a note, vaso and vasopressin means vessel. Vasopressin has many functions related to the circulatory system. A sidebar. If you have ever felt lightheaded, maybe you stood up too fast, or you're straining too much or too hard, that is vasovagal. Vessels and the vagus nerve, a major cranium nerve for regulating and acting on the parasympathetic side of the nervous system, the calming side. Vasopressin has vast roles in blood pressure, sodium regulation, and interacting with water. Vasopressin is seen more in males than females, and it does interact with that crude stress system and fear, anxiety, and aggression. Anyway, oxytocin and vasopressin, by the way of the magnocellular and parvocellular, are released in the hypothalamus. Remember, we've discussed the hypothalamus at least a few times. Oxytocin and vasopressin are transported by dendrites and axons. Remember how cells connect and communicate to each other. And remember the genetic and protein implications covered in episode 3. Oxytocin is distributed to sensory areas of the brain, in large part for social relevant stimuli. Oxytocin mediates communication in the amygdala. Remember the amygdala, mostly from autism and anxiety episode. Oxytocin mediates fear response and coping between two subdivisions in the amygdala. And oxytocin is used for synaptic transmission between the BNST, the bed nucleus of the stria terminalis, and the hypothalamus. More from the autism and anxiety episode. Remember, those two connections, the amygdala to the bed stria terminalis, was consistent in those three dynamic structures and components that we covered in the autism and anxiety episode. Oxytocin also interacts closely to dopamine and serotonin, those two neuromodulators previously discussed. Remember, dopamine is wanting, and serotonin is having. Oxytocin also interacts with GABA. Remember, the excitation is glutamate. The inhibition is GABA. So this makes up that EI imbalance that is constant and consistent. Perhaps the most consistent thing in autism research about biology is this imbalance of excitation and inhibition. We will discuss more on GABA, the inhibition part. Also, oxytocin increases trust. Remember that the root of that pair bonding and mother-child development. So some overall trust. Some empathy. Remember we discussed the two types of empathy from magnocellular and parvocellular. And eye contact. Oxytocin is related to eye contact, face memory, and generosity. These peptides decreases activity of negative emotional experiences. And guess where? The amygdala, the anterior cingulate cortex, and the insula. All areas from Autism and Adaptive Responses episode. The peptides increase responses for automatic and effortful emotional regulation in the medial prefrontal cortex. Also the region of interest in Autism and Adaptive Responses episode. The peptides targets motivational and rewarding regions by initiating and sustaining socialness by acting on the ventral tegmental area. Remember from Autism and Anxiety, the Autism and Anxiety episode, the VTA is the spot for providing valence, or attaching how we feel in that moment, in that environment. Hopefully, this is all coming together now. Oxytocin also targets 3 of the 4 areas in the striatum: the putamen and caudate, which is the dorsal part of the striatum. The putamen and caudate is responsible for stimulus response memories. Remember, we've discussed stimulus responses, those reflexive actions all humans do in response to something in the environment, the external stimuli. The stimulus response intends to return the individual back to homeostasis, back to the comfort that they prefer, that they've learned, that they've developed through neuroplasticity, returning us as the living organism back to comfort. And remember, 1, because our nervous system mostly just responds based on who we are, based on our lifetime of neuroplasticity. And 2, change is hard. Change is hard because the nervous system doesn't like to work. It likes to reflexively respond, pass things on to what it knows, how it knows how to operate, acting in a way it knows. See, this is more than a discussion on autism. This is human life. We are who we are. A brief note, a brief review of this study comparing autistics and non-autistics. Reward processing is altered in large part at the cellular level with the autism group, the autistic groups, using 2 activities. The first one is monetary rewards found in the ventral striatum. Remember, the ventral striatum in large part is the nucleus accumbens, our hotspot for rewards. And the ACC, which we discussed in depth in a previous episode, and the prefrontal cortex. And the second activity was reduced activity in the striatum during positive socialness. For instance, seeing smiling faces. And remember, theory of mind, also called cognitive empathy, which we discussed earlier. This is a super deficit, but effective empathy is not. It is a possible superpower. We will discuss more on that in the future. So you can see from the study the differences between autistics and non-autistics and how different brain regions are activated based on those 2 activities, receiving monetary rewards and experiencing positive socialness. This lack of reward attached to socialness prevents social learning opportunities as far back as that critical period. And if you understand the social phenotypes of autism, they are very, they are behind or uneducated and poor. Things like loud and soft tone, prosody, when and how to join and end a conversation, speaking too much on a specific topic, despite obvious, well, to others, not so much for us, obvious disinterest in the topic by the listener. In addition to these areas, there are hypoconnectivity to downstream or connecting brain regions used in socialness, providing more proof and insight on what causes the autistic phenotypes, explaining what and who we are. This is giving you understanding to maybe calm any tendency of wanting to change someone with autism because they are different than you. I did not say you can't help them build social skills. I would not say that. However, if an autistic prefers being less active in socialness, this so-called autistic aloneness. Remember the paper by Leo Kanner, that first paper on autism released in 1943. He highlighted this quite extensively. Be mindful. Autism gives us the ability to be comfortable within ourselves. And this is a path for developing tremendous superpowers. In autism, data exists on lower levels of peripheral and central oxytocin, and deficient and altered expression of oxytocin receptors in both animal and human research. In addition, data also show the lower plasma oxytocin are present in children and not so much adolescent or adult autistics. This is critical in the role of oxytocin in development. I think this is a good finding and correlation. A meta-analysis using 18 studies examined and determined this finding, and that was released in 2021. Oxytocin and serotonin. Oxytocin and serotonin appears to be the driving force and the role of supporting anxiety-like features and supports socialness. The dorsal raphe, the raphe is the brain serotonin, receives oxytocin fibers, and the raphe has oxytocin receptors. This action causes a release of serotonin, specifically to frontal brain regions. And remember, serotonin's role in active versus passive coping. In contrast, studies show genetically removing this connection after childbirth resulted in offspring loss. Remember the developmental roles. The impaired nursing, increased aggression, and behavior complications. When oxytocin and serotonin work in concert, it provides a perception of rewarding socialness occurring. In other words, when socialness is rewarding, coordinated activity of oxytocin and serotonin is required, and it goes to that ventral striatum area, the nucleus accumbens. Said differently, a lack of oxytocin prevents social enjoyment. And now, just a brief note, when we discuss female versus male autistics, the nucleus accumbens and oxytocin is going to be huge. This was a huge finding. Anyway, data on various modeled organisms and humans show various oxytocin and serotonin connections, including in the prefrontal cortex, that area that makes us the superior species on Earth, and the amygdala, the striatal areas, and interesting, serotonin regulates the release of oxytocin in one of the areas of the hypothalamus. So, 3 things of interest here. 1, the reward processing. 2, the fear response. and 3, the social emotional processing. Oxytocin and dopamine. The roles in dopamine primarily stick to the main roles of dopamine. That is, connecting brain regions based on wanting, motivation, and craving. What you find rewarding, and aspects of cognitive processing and sensory gating. This is a good one. Remember, dopamine is a neuromodulator, and it conducts whole systems. It turns things on, turns certain brain regions on, or whole systems throughout the body. It activates them, and it turns things off, little brain regions, or entire systems, biological systems. It inactivates them, and it regulates action through the nervous system. Dopamine has 2 receptor types. Dopamine has 5 total receptors broken down into 2 types. D1 is excitation, and that's dopamine receptor 1 and 5. And D2 is inhibition. These are dopamine receptors 2, 3, and 4. D2 type receptors are inhibition. So, now we will introduce GABA, which is inhibition. In autism, dysregulation of GABA receptors exists in the data. Remember one of those components or reasons that gives us the EI imbalance. Remember a critical role of GABA, which is inhibitory, turning things off or quieting the brain. One of GABA's main roles is regulating sensations via that thalamocortical path. These abnormal GABA receptors are also found in seizures, remember the closeness to epilepsy, and learning disabilities, and our primary topic, in social and cognitive dysfunctions. The excitation inhibition needs both oxytocin and GABA for a proper balance. For the developing brain, these components are critical for proper development. A study shows aberrations in these areas are a cause of autistic phenotypes. Also, abnormal GABA development in the dopaminergic areas of the brain is our region of interest. This expands on some dysfunction of the excitation and inhibition balance and offers a topic in recent research of pathophysiology of autism. In addition, neurogenesis, the development of neurons. Remember, cells divide, and neurite growth and synapses formation involve many factors. Nothing singular. These neuropeptides, alongside GABA, are critical for these roles. Okay, before we end, I just want to cover intranasal oxytocin as a therapeutic option for autism or for those autistic phenotypes. Intranasal oxytocin administration penetrates the brain. It crosses the blood-brain barrier with capillary beds and induces cognitive, emotional, and behavioral changes, mostly related to socialness. To no surprise, for that reason, data exists on testing intranasal oxytocin for autism superdeficits, social anxiety, increasing peer-to-peer capabilities, or said differently, acting on those roles oxytocin has in social functioning discussed earlier. The data on intranasal oxytocin is both inconsistent and low risk, meaning little to zero side effects. Criteria for the intranasal oxytocin include standardization of dosage, frequency, formulation, differences in sex, and devices used for administration. 2 points to consider. There's an idea gender differences is a primary cause of the inconsistent data. And intranasal oxytocin is shown to improve socialness, or more precisely, shown to suppress anxiety in healthy participants. The reason we will explore this option is because there is proof, and it is in the so-called low-risk category as a helpful option for autism. There are several things to know here, several takeaways to consider. 1, studies do show improvements, and a few meta-analyses confirm this. Intranasal oxytocin, this approach, has been around for about 20 years now, I believe 2003. So, some data has collected. The second thing to consider is it is low risk, and this ought to be a tremendous factor. If it works, it works. If it doesn't, okay, it doesn't. 3, it is unknown if intranasal mimics the endogenous amounts released in the brain. The dosage has to really be pinpointed. 4, there is a chance intranasal oxytocin activates broad serotonin across the brain. In other words, it might lack specificity. And lastly, number 5, and this is a big one, intranasal appears to target the magnocellular pathway, which is more peripheral. So it acts on hormones, and it blunts stress responses in the hormonal systems, such as cortisol, when in reality, the idea is acting on the central pathways, that the areas responsible for the brain regions, that cellular activity. You want more neuropeptide or neurotransmitter and less hormone, so it can target the nucleus accumbens. Remember, co-activating with serotonin and oxytocin to reach the nucleus accumbens. That is the primary target. And that works by the way of the parvocellular function, or that parvocellular path, and not the magnocellular. If you are listening and enjoy the episode or enjoy the podcast, feel free to leave a review or rating. In podcasting, reviews, ratings, and downloads are huge, and I very much appreciate your feedback. You can email me at info.fromthespectrum@gmail.com. And thank you for listening to From the Spectrum podcast.